In this video, we're going to look at factoring. When we factor, we are going to factor completely. That means to go through all your factoring methods and factor until everything is a linear function, or it can no longer linear expression, excuse me, or can no longer be factored. The first thing we do always is look for the greatest common factor. And we're gonna go through a lot of examples quickly in this video, so be sure to pause often and try the problem on your own before watching the solution. So here, these both have a 3 in common and also a y. And when you take out a greatest common factor, you divide to see what is left in the parenthesis. So in this case, it leaves 2y and plus 1. That plus 1 is a common mistake. Do not forget your plus 1 there. This we can factor with a binomial too. So if you look at these terms, this is all one term and this is all one term. So this has, they each have a y minus 1 squared. So you can take out a y minus 1 squared, and then you're left with, when you divide by y minus 1 squared, you're left with y. And when you divide by y minus 1 squared, you're left with z. And there's nothing else to be factored, so you're done there. Factoring by grouping, this is commonly used in the AC method to factor a quadratic. But if you have 4 terms, you look to factor by grouping. And that's where we're going to look at these first 2 terms and look and see if there's a greatest common factor between these two. And there is. They have an x in common. And that leaves us with x and then minus y when you divide out that x. And then these have a negative a in common. It leaves us with x minus y. And so a common question is, well, why do I take out the negative? How do I know to take out the negative? And the answer is because if you take out the negative, it makes this parenthesis look like this parenthesis. If you leave the negative in there, then they don't look the same. And that's what we want with factor by grouping. If these look the same, then we can continue factoring because that's my new greatest common factor, x minus y. And then you can just write everything that's left, x minus a in this case. Okay, with these trinomials, or the ones that have a quadratic form, this x squared plus bx plus c, there's a lot of different methods we can use here. If this is a is equal to 1, so the number in front is 1, then we're going to use this shortcut method. You can also kind of guess and check on these too. So here, notice that a is 1. And so now we're looking for 2 numbers that multiply to 8 and add to the middle term, negative 6. And this is like just a guess and check thing. So what are those 2 numbers? Well, if I had negative 4 and negative 2, then those numbers multiply to 8 and add to negative 6. And so because a is 1, and only because a is 1, I can just jump down to x times x, and then minus 4 minus 2. And in order doesn't matter. You could put the negative 2 first. But there's no need to do any kind of like long method if a is 1. Here, before, and I forgot to mention it up here, but always look for a greatest common factor. So before we do the AC method, these all have a negative 2 in common. And so bring that out. And you may say, well, why negative and not just 2? And the reason for that is because this quadratic form is much simpler to factor if the quadratic coefficient is positive. So the number in front of the squared term, if it's positive, it's a lot easier to deal with. So the negative 2 just kind of hangs out. And then we find 2 numbers that multiply to negative 10 and add to negative 9. And that'd be negative 10 and positive 1. And now because there's no, or the coefficient in front of w squared is 1, we can take our shortcut and just write these numbers here, these kind of magic numbers. Another thing that might be useful is just to work backwards on this momentarily, or just quickly, just to see, well, if I were to FOIL this, I'd do w times w and get w squared. and then I'd get 1w and negative 10w, that's negative 9w, and then negative 10 times 1 is negative 10. And so that's factoring is just rewriting an expression. They're equal. So if you multiply the parentheses out, you should get back to where you started. Okay, then this one, once again, look for a greatest common factor, which is m cubed. And so then we're back to our quadratic form. M to the first, and then plus 100. And we need two numbers that multiply to 100 and add to 20. And so that would be 10 and 10. Oops, this would be m to the m squared. M to the second there, because I took out the m cubed. So the m cubed just hangs out, does its thing out front. And then these two numbers, because a is 1, and only because a is 1, I can take this shortcut. And we have what's called a perfect square trinomial. And so we can write it as m plus 10 squared. Here, these are some helpful patterns, especially if you want to do like some guessing and checking. And so if you look at the signs, like if the last one's negative, then the signs have to be different. And so it could be like plus minus and then minus plus is how you could show that. But if the last number is positive, then these signs should be the same because they have to make a positive number. So the same signs. That's a good way to like check your work, or also if you just want to guess and check, like kind of using foiling and see what works out with the factoring, you could do that too. Okay, with trinomials where a is not equal to 1, we have to do a longer method. There's a few different ways to do this. We'll do one way, but you can also guess and check on this too. You're going to do the same thing, except you got to do as before. You're going to multiply a times c, but this time it's 6 times 1, so it's 6 and multiply to 5. And so you find those two numbers, and then so that's plus 3 and 2. And then you're going to take this term and rewrite it, because 3 plus 2 is 5. So you can rewrite this as 6w squared plus 3w plus 2w plus 1. So take a minute, pause this, or think about it. We didn't change the value. We just rewrote this as 3 plus 2. And then now we're going to factor by grouping, because now we have 4 terms. And if you did it right, it should factor by grouping. Or if it does in fact factor, you should be able to factor by grouping. Here, there's nothing in common, so you take out a plus 1. And now you have a greatest common factor of 2w plus 1 or 3w plus 1. A lot of people don't see that that's a greatest common factor right away, and they just think, well, these look the same, which is good, so I'm going to write that as 1 parenthesis. And then my other term, 3w and then plus 1, my other terms, make up my other parenthesis. That's okay too. Another method people use to kind of get here is they say, well, what I'm going to do is I'm going to divide everything by the number in front up here. So you take 6 or 3 and divide it by 6, and then 2 and divide it by 6. And then reduce those fractions. So this would be 1/3, and this would be 1/2. And so this is a shortcut, but the shortcut is this number is the number in front of the variable, and this number is the constant. Same thing over here. So this would be 2w plus 1. This would be 3w plus 1. So that's a nice little shortcut to use. It's not quite as like step by step, but it's good to do. Okay, so here we want two numbers that multiply to negative 12 and then add to negative 3. And so those numbers would be, what would they be? 4 and 3 do not work. 6 and 2. do not work. And so since we cannot find any of those numbers, none of those numbers work. And you could try like list them out: 1 and 12, 1 and -12, 2 and 6, 3 and 4, and that's all of them. The sign's got to be different, but none of them are going to give you -3, and so that's not factorable, or we just say it's prime. Okay, there are some shortcuts to the AC method, or these special products. The first one is the difference of squares. And so if you have a squared minus b squared, then you get a plus b, a minus b for the factors. And you can do this just kind of quickly, right? You could say, well, if we first is recognized, so this is a perfect square, x squared, and this is a perfect square, 16, and it's subtraction. If it's addition, it doesn't work. And so this would just be x plus 4, and then x minus 4. Take a minute, pause the video if you haven't already, and complete these next two. Here it'd be 7a plus 8b when you take the square root, and 7a minus 8b. This one is one you got to watch for because it's 4x squared. X squared is the square root of x to the fourth plus 1. And then 4x squared minus 1. However, now you're in a situation where you can factor again because this is another difference of squares right here. And that's hard to catch. But if you have to factor multiple ways, difference of squares is a common one to have to do it with. A quick note about the sums of squares. Sums of squares are prime, meaning you cannot factor sums of squares. So x squared plus 25, that's prime. You're done. There's nothing else to do in terms of factoring. Okay, so one thing to recognize with the difference in difference of squares, is that it's just memorization. You memorize the method, and then you're able to factor it. The same is true with the difference of cubes, except it's much more difficult to memorize. So we have a cubed plus b cubed. That is in the form a plus b. So you cube root each of these. And then we're going to use SOFAs, or I like to use SOFAs, to help you memorize this. So the s is square the first term. So that's a squared. And then o is opposite sign. And this was positive. This was positive here, so that's negative. F is first times second. So that's a times b, this times this. And then a is always positive. So this is plus. And then square the second is square this term right here, which is b squared. So this is hard to memorize. It'll take some practice. I'm going to try to do these quickly, or do this quickly, and then so you can see that. So pause it, but then try to find the rhythm of it. So first thing you do is take the cube root of both of them, and then you have to follow the method. So it's SOFAs. So it's square the first, opposite sign, first times second, always positive, square the last. So pause that and look at it again and to see that pattern. And then try the pattern down here with 8x cubed minus 1 for that difference of cubes. So first is to take the cube root of both. So it's 2x and then minus 1. And then fill in the pattern. So you square the first, you got to square the whole thing. So it's 4x squared. The opposite sign, it was negative. Now it's positive. First times second, and this is where the acronym gets a little weird. You have to ignore the sign, right? It's just 2x times 1. You've already dealt with the opposite sign here. Always positive, and then square the second. The nice thing about difference of cubes is this should never factor again, right here. So you can you're just done after that step. But it is a thing, you have to memorize it. It's not very intuitive. The why is pretty long to see why it works, but that's how those factor. Okay, and then the last thing we'll do is use the quadratic form, but just kind of in trickier context. And the thing to do with these questions is to kind of just pretend that it looks like a normal, we'll use u for it, but what if instead of m plus squared, it was u squared plus 2u minus 3? Like, what if you had to factor that? You'd say, well, I can do that. I just do u plus 3 and u minus 1, because I need two numbers that multiply to negative 3 and add to 2. Well, if we get trickier, that's fine. We use the same pattern, but now u is this m plus 2. So this would factor down to m plus 2 and then plus 3, and then times m plus 2 minus 1. And then in math, you should probably go ahead and combine like terms. So we have m plus 5 and then m plus 1. Those aren't quite as common, but this kind of u substitution thing is okay to do. And maybe even we'll write that down to make it a little more formal. With this one, notice the form. This is 8x to the 8th. I'm going to rewrite that. It's kind of small. Minus x to the 4th minus 6. And this pattern follows this quadratic form, where in a quadratic, if we go back up here, this exponent is half of this exponent. The same is true. So if we just like kind of guessed and checked our way through this, well, you know how to deal with the numbers, because we need two numbers that multiply to negative 6 and add to negative 1. So that's negative 3 and 2. And then for this to be x to the 8th and this to be x to the 4th, then this term has got to be x to the 4th. And so does this one. And so you might notice that you could see a pattern here which would hold. If it's quadratic form, then this exponent should match this exponent each time. And you do that all the time. Up here, this u to the first is u to the first here and u to the first here. So the larger exponents can confuse you, but the method's the same way. You just have to think about the exponents at the end. Okay, that was a lot of factoring. Good luck, and reach out if you have any questions.